Good morning, students. Today we see the performing two BCD numbers additions. Means point is the BCD adder, means how to perform the addition in between two BCD numbers. Okay, so first we see what is the BCD adder. So in the BCD adder is a circuit that adds two BCD digits and produces a sum of digits also in BCD. Okay, means if you want to perform the addition in between the two BCD numbers, then you have two BCD numbers. Okay, and result it should be in the BCD form. Okay, result it should be in the BCD form, means in this case there are two inputs which is the in BCD form. Okay, and here you also generate the output which is also in the form of BCD. This is the most important point. Okay, so what is the rules behind while performing these BCD additions? So there are some rules. So first rule is the add two numbers using rules of binary additions, means here uh, while you are performing the addition, then you use the simple rule of binary addition. Okay, so if the 4 bit sum is greater than 9, if the 4 bit sum is greater than 9, why I said here 4 bit? Because BCD numbers are represented in 4 bits. Okay, BCD numbers are represented always in 4 bits. So if the 4 bit sum is greater than 9, or if carry is generated, then the sum is invalid. Okay, this point is so important. Means here if you want to perform the addition of BCD numbers which are the 4 bits. Okay, and here if the carry is generated while performing the addition or while getting the result, and if you observe if there is a carry, at that time the sum is invalid, means your answer is invalid, means your result is invalid. Why your result is invalid? Because here carry is generated, because here carry is generated. And if you want to get the valid result, if you want to get the valid result, at that time you should add 6, you should add 6. What is the binary equivalent of 6? 0 1 1 0. Okay, so here these 4 bits are added into the coming results. Okay, whatever you got the results, where in that result carry is generated. Okay, if the carry is generated, then here you add the 6 into that result, then you will get the valid result. Okay, valid BCD results. This is the first rule, means when results came, at that time you should check whether the carry is generated or not. If the carry is generated, then your result is a invalid result, and here you have to add 6 into that result. Okay, if carry is not generated, then result is valid. Okay, then result is valid, and in this case you don't need to add 6 into that result. Okay, this is the first rule. And next rule is the while you are performing the addition, and if the result is greater than 9, if the result is greater than 9, at that time you should again add 6 into that result, then you get the valid BCD results. Okay, so here are the three rules of BCD additions. First rule is the you performing the addition of two numbers by using simple rule of the binary addition. When you performing the addition, then you check that whether the result is greater than 9 or not. If the result is greater than 9, then you add 6 into that result, then you get the valid BCD results. Okay, means we already told you your output is also in the BCD format, means your input is BCD as well as your output is BCD. But if the result is greater than 9, then this is the invalid BCD. So in this case you just add 6 into that result, then you get the valid BCD results. This is the second. And third rule is the while you are performing the addition, and here if you observe that there is a carry, So, in this case you can also add 6 into that particular result, then you get the proper valid BCD results. Okay. So, these 2 points are so important when we add the 6 into that particular result. Okay. When carry is generated, and second is the when result is greater than 9. Okay. So, if you see the last point, what is the last point? If the 4 bit sum is less than 9 or equal to 9, then sum is proper form. Means in this case there is no need to add 6 into that particular result. Means your sum, means your result is less than 9 or equal to 9, then whatever result is in the proper form, means proper BCD form. So, in this case there is no need to add 6 into that particular results. Okay. So, I think you got this point, what is the BCD adder. So, in the next slide we implement this BCD adder. Okay. So, for BCD adder, here you see that there is one truth table, in the next there is a K map, and last is the logic diagram. Okay. Okay, this is the your next slide. In this slide you observe that from the left hand side, first you see the truth table, next you see the K map, and finally here you see the logic diagram. First we see the truth table. Okay. And if you observe this truth table, then you get that from 0 to 9, the output is 0. From 0 to 9 the output is 0, but after 9, means from 10 their output is the 1. From 10 there is output is 1, means here this is the truth table for BCD adder. And for the BCD adder, how many inputs? 4 inputs, because BCD number are always represented in 4 bits. Okay. So, these 4 bits are S0, S1, S2 and S3. Means how many possible conditions are there? There are the 4 inputs, that is why there is a 2 raised to 4, means this is the 16th. So, there are 16 possible conditions. It starts from the 0 and ends to the 15th, means up to 16 possible conditions. So, out of this 16 possible conditions, up to the 9 the result is 0, up to the 9 the result is 0, but after 9 the output is 1. Why it is? Because if the result is less than 9, or equal to 9, then result is proper BCD format. Okay. So, there is no any step to carry. Okay. Whatever your result is getting, this result is final, there is no any further steps. Okay. So, here output is 0, but after 9, or it starts from the 10 to 15. Okay, 10 to 15, this result is greater than 9. So, in this case here you add something, or here you want to perform further next steps. In that step, here you add 6 into that particular results. So, in this case the output from 10 to 15, it is take it as a 1. Okay. So, this is regarding to the truth table. Means in the truth table output from 0 to 9 is the 0, and output from 10 to 15 is the 1. Why it is a 1? Because here you have to perform something, means here you have to perform something, means here you have here you add 6 into that particular result, then you get the final results. Okay. So, next we see the K map. Of this truth table. Okay. So, in this truth table actually some parts are missing into this truth table. Here 4 by 4 matrix is there. Okay. Means there are the 4 variables. So, how many boxes are there? 2 raised to 4, 16 boxes are there, means here 4 columns and 4 rows are there. Okay. So, in this some parts are missing, means at the first column you make one cross line, okay, and below the cross line you write the S0 S1 S1 S0, you write the S1 S0, and above the cross line you have to write the S3 S2 S3 S2, means from horizontally you put the two variables S1 S0, and for vertically you put the two variables S3 and S2. Okay, this is the most important point. I think in previous lecture some network issues are there. Okay, so in that lecture I draw this truth table. Okay, K map, I draw this K map, and in that K map I return S1 S0, then may draw the one cross line, and above the cross line I return S3 S2. Okay, and on the top of the column I return S3 bar S2 bar. In the on the second column I return S3 bar S2. On the top of the third column I return S3 S2, and last column I return S3 S2 bar S3 S2 bar. Okay, likewise I return onto the rows from first to fourth. On the first row I return as a S1 bar S0 bar, then S1 bar S0, then S1 S0, and lastly I return S1 S0 bar. Okay, and in the boxes means in the first column first row, I return as a Y0. Next then I go to the vertically from Y0, then I return Y1, then Y3, then Y2, then Y5, Y6, Y8, Y7. Okay, likewise I specify the name of that particular box, means what is the which output is returned into that particular box. If you want to write the output for fourth column first row, if you want to write the column output for if you want to write the output for third column and third row, so what is the output for third column third row? This is the Y15, I already draw all this. Okay, so some part is missing into that K map, so you keep in mind and do from your side. So in this K map you observe that there is one chord is formed. Okay, there is one chord is formed in the third column, and vertical chord is formed. Okay, and says next from the third row and fourth row there is again one chord is formed. Okay, means here two chords are formed. If you see the first chord, which is the vertically, so in this chord which variable is reduced? S1 and S0 variables are reduced. Okay, means I already told you when chord is formed then two variables are reduced. Okay, so first chord which is vertically, which is present in the third column, so in that chord which variables are reduced? S1 and S0 are reduced, and this third column on the top of the third column which variables present? Only S3 and S2 variables are present. So here I return as a Y is equal to S3 S2, Y is equal to S3 S2 plus next S3 S1. This output came because of the second chord. Okay, because of the creating of the second chord. In the second chord you observe that this second chord is generated for third and fourth row, Okay, so what is the output for third row and fourth row? S1 for the third row, this is the S1 S0, both are the positive, and for the fourth row S1 S0 bar, means here S0 variable is reduced because in the third row S0 as a positive and and the fourth row S0 it becomes negative. So here S0 variable is reduced, means only S1 variable is present. And in the if you see the vertically, in the vertically only third column and fourth columns are present. In the third column, what is the output for third column? S3 S2 both are the positive, but in the fourth column this is the S3 S2 bar, means here S2 variable is reduced, only S3 variable is present. So in this code only S3 is present, means in vertically S3 is present, horizontally S1 is present. So here output is S3 S1. So here output is S3 S1, means from this K map you get the output equation, final Boolean output equation, which is y is equal to S3 S2 plus S3 S1, S3 S2 plus S3 S1. Okay. So with the help of this Boolean equation, final Boolean equation, you can draw the final logic diagram for this BCD adder. Okay. So here you don't use this final logic diagram. Okay. We see the final logic diagram in the next slide. This is the final logic diagram for BCD circuit, BCD adder circuit diagram. Okay, this is the final logic diagram for BCD adder. So in this BCD adder circuit, there are the two ICs are used. Okay, what is the name of this IC? 7483. Okay, so here two BCD adder ICs are used. IC is nothing but integrated circuit, means there is one chip. And what is the name of this chip? 7483. And what is the use of this chip? For the use of this chip is to performing the addition of two BCD numbers. Means if you want to perform the addition of two BCD numbers, at that time you require one IC. IC is nothing but integrated circuit. So what is the use of this IC? For performing the addition of two BCD numbers. Okay. So here you see the first IC, which is at the top. Okay. So you observe that there are the two BCD inputs. Okay, BCD input 1 and BCD input 2. What is the BCD input 1? A1, A2, A3, A4. This is your first BCD input. Okay, and what is the second BCD input? B1, B2, B3, B4. Means here two BCD inputs are present, and here onto these two BCD inputs you apply the operation. Which operation? Addition operation is performing. Okay. So what is the output of this BCD addition? Output of BCD addition, here you observe that S1, S2, S3 and S4, but in the K map or in the truth table we take the output which starts from the S0, not the S1. So here you make one correction. Here output pins written as a S1, S2, S3, S4, but instead of writing S1, S2, S3, S4, here you write S0, S1, S2, S3. Means instead of writing S1 you write the S0, instead of writing S2 you write the S1, instead of writing S3 you write the S2, and finally instead of writing S4 you write the S3. This is one mistake in that BCD adder circuit. Okay. So if you see this IC, onto this IC there are the two inputs and one outputs. Okay, which inputs? BCD inputs are present, A1, A2, A3, A4. Next B1, B2, B3, B4. And what is the output? S1, S0, S1, S2 and S3. And there is one carry, C in is carry. And we already discussed when you want to perform the addition of two BCD numbers, at that time you should check the result of that BCD addition. If the result contains carry, okay, then you add the 6. And second, when the result is greater than 9, then you add 6 into that particular result, then you get the final results. Okay, so for adding 6 we calculating the equation in the previous slide. What is the equation of the adding 6 for previous? What is the equation? Y is equal to S3 S2 plus S3 S1 means what is the use of this equation? For add 6 into that particular result, whose result is greater than 9 or whose carry is generated into that result. At that time you want to add 6, and for that purpose here we are find out the logic equation, Boolean logic equation. Y is equal to S3 S2 plus S3 S1. So here we implement this. So what is the equation? Y is equal to S3 S2 means here two variables, and here there are the multiplications. So here you are using the AND gate. Okay, first AND gate. So 7408, this is the name of the AND gate, and for this AND gate there are the two inputs S3 S2, and at the down you see again one AND gate is present. And what is the input for this AND gate? S3 and S1 means here you, and here the output of this AND gate is connected to the OR gate, means here you perform the addition. Of the two multiplications, okay, of the two AND gate outputs. So what is the output for this OR gate? S3 S2 plus S3 S1. What is the output of this OR gate? S3 S2 plus S3 S1. Okay, and then you go further and you take the carry. If the carry is generated, again you take the one XOR gate again, and then this output of this OR gate is connected to the second IC, which is connected to the second IC, means second BCD inputs. Okay, means whatever result is came after performing the two BCD inputs, this is directly connected to the A1, A2, A3, A4, means S0 to S3 pins are directly connected to the A1 to A4 pins. Okay, and same means if the result is greater than, if the result is not greater than 9 or there is no any carry generated, then this result is same. It take it as a same, means there is no performing any operation. But if the carry is generated or result is greater than 9, then you perform this operation, means you are using the two AND gates and two OR gates, and the output of this logic is connected to the second BCD inputs, which is the B1, B2, B3, B4, means here you are performing this addition, and then finally you get the result S1, S2, S3, S4, but instead of S1 you can write the S0, means result starts from the S0 to S3. This is very simple logic, means in this BCD adder circuit diagram you observe that there are the two ICs are present. Okay, what is the name of this IC? 7483. What is the use of this IC? For performing the addition of two BCD numbers, means there are the two BCD inputs. So first you perform the addition, simple addition. When result is getting, then you check whether the result is greater than 9 or not, or whether the carry is generated or not. If the carry is generated, then you perform the operations, means then you are using the two AND gates and two OR gates. Then output of this OR gate is connected to the second IC and BCD, the second BCD inputs. Then you get the final valid BCD results. Okay, then you get the final valid BCD results. Okay, I think you got this point. My suggestion to all, here you take one example, means BCD input 1 and BCD input 2. Suppose you take the example 5 and 3. If you want to perform the addition of first BCD number 5 and second BCD number 3, means at the BCD input 1, what is the inputs? 0 1 0 1. Okay, and what is the second input? 0 0 1 1. Okay, so you perform the addition, then you check whether the carry is generated or result is greater than 9 or not. Okay, you take any inputs. म्हणजे first you take input which is the result is less than 9, and then you take another example whether the result is greater than 9. You implement from your side, you check how this circuit is follow, how this circuit is executed, for that purpose you take the two examples. First you take the two BCD numbers whose result is 9 and there is no any carry generated. This is your first example. Then you take the second example whose result is greater than 9 and carry is generated. You take the two examples and implement onto this logic diagram, and here you check that whether your result is came or not, whether your proper result is came or not. If you observe the second IC and second BCD input B4, B3, B2, B1, if you observe the second IC and onto the second IC you observe second BCD inputs, it should be 0 1 1 0, it should be 0 1 1 0. Why it should be 0 1 1 0? Because this second input it should be 6, means if the result is greater than 9, at that time you require to add 6, or if the carry is generated, at that time you require to add 6. Okay, so onto the second IC, second input it should be 6. If you observe that 6 add 6, this means before it should be 0. Okay, so you see that the before is connected to the ground. Okay, and B3 B2 inputs is connected to the output of OR gate, and I think this is the 1 1, this is the 1 because output of OR gate is 1 because carry is generated, or result is greater than 9, therefore the output of OR gate should be 1. So this one is connected to the B3 and B2, means B4 is permanently connected ground, and B2 B3 is permanently connected to 1, and B1 is again connected to the ground. So this is equivalent to 0 1 1 0, this is equivalent to 0 1 1 0, means onto the second IC second input it should be 6, Okay, so I appeal all you take two examples and implement onto this logic diagram and check that whether the result is getting or not, whether the proper result is getting or not. Okay, so this is the BCD adder. So here we stop here. I also send the next recorded video onto the look ahead carry generator. So this recorded video, it is only for performing the BCD addition, means here you have two BCD inputs and here you want to perform the operation onto this BCD input. Which operation? Addition operation. So while performing the addition operation onto the BCD inputs, then which condition you have to be checked, it should be known for you. So if the result is less than 9 or equal to 9, then there is no any further operation, but if the result is greater than 9 or carry is generated, then some operation is performed onto that result and then you get the proper results. Okay, so in this lecture we have seen that how to perform the addition of two BCD numbers, So in the next recorded video I will take the point look ahead carry generated, this in this next lecture. Okay, so thank you and take care.